We're going to work on solving quadratics, specifically by factoring. We've gone over before how to use a trial and error method. This time we're going to use an actual algebraic method to solve this. So this is a profit function, okay, for skateboards. And what it says is this is essentially the amount of money they're going to make, depending on what our x value is. Very first question they're going to ask us with this profit function is, what is the break-even point? So break-even question mark. A break-even point will be when our profit is equal to what amount? Anyone know? Zero. I want our profit to be equal to 0. Now, because this is the function they've given us, essentially what we want is one side of the profit function, and we'll say that we're going to call this side our p at x. We want it to be equal to 0. So we're going to move our 63 to the other side of the equation. So our profit function, p at x, is equal to negative 63 plus 133x minus 14x. Now again, we said we wanted our profit to be what for it to be break even? 0. So we're going to substitute the value 0 in for p at x. In other words, the y value. Our profit, x is probably our amount of skateboards we need to sell in order to make a certain amount of profit. We need to figure out how many skateboards we need to sell in order to create 0 sum. So $0 in profit. So 0 is equal to, and I'm going to rearrange this. What form is this quadratic in right now? It's in standard, but why does it look a little different from what we're used to seeing with standard?
Because the x squared is at the last.
Yeah, that's right. It looks like we've done the reverse order where our variable with the highest exponent is farthest to the right, then the second highest, and then the lowest. Usually this is our first term, then our second term, and our third term. So what we're going to do, just so it's easier for you guys, we're going to rearrange it. When I go to rearrange it, what would be my first term if I want it to be the variable with the highest exponent? That's right. We have to take the value in front and keep it when we move it. So we have negative 14x squared. Then we'll still have the positive 133x and minus 63. So what is the very first step to any type of factoring? Common factoring. Do you guys, can you think of a common factor? We'll call it common factoring. What would it be? 7, that's right. Now, my first value is what? A negative, and usually it's easiest to factor when we have a positive value. So we're going to factor out the negative along with that 7. So in fact, our common factor is going to be negative 7. We're going to be taking negative 7 out of all 3 of the terms. So this will still read 0 is equal to the negative 7 comes outside. When we divide negative 14 by negative 7, what will we get? Right. So 2x squared. Now this is a positive divided by a negative, so we're going to have a negative value. And when we take 7 out of our 133, is that what it is? 19?
19?
Yeah, that's right. 19x. And when we divide negative 63 by negative 7, what will we get? Positive 9, right?
9.
Positive 9. Good. Okay, so now that we have this part in here we want to focus on. This is our trinomial, and we want to work on our factoring. So remember our style of factoring. We're going to take the factors of the first term, which will really just be 2 and 1, and the factors of the last term, which will be 1 and 9 and 3 and 3. And we need these factors to add up to our middle term, which is negative 19. Technically, there's an x. Okay. So here's where we do use a little bit of trial and error. 2 by 1 and 1 by 9, what does that give us? Doesn't work. So let's go across. 1 and 1 and 2 and 9 gives us 18 and 1. Will that work?
Yeah.
Okay, but they'll both have to be what in order to make negative 19?
Negative.
They'll both have to be negative, right? So when we multiply across these, we're going to get negative 18 and negative 1, which means this 1 needs to be negative, and this 9 needs to be negative. Now let's just double check. What is negative 1 times negative 9? Positive 9. So we know it still works as a factor. So when we go to plug this in, we still have 0 is equal to, our negative 7 is still on the outside, and we have 2 sets of brackets. Okay. Now, these will be the first terms, and I'm going to put them in either bracket. We'll start with 2x and 1x. Now remember, this is the important part. Because I multiply 2x by negative 9, they have to go in opposite brackets, so the negative 9 will go here. And because we multiplied 1x by negative 1, they will have to go into opposite brackets. Okay. So, I'm just going to rewrite this in black. Nothing has changed. Negative 7 times 2x minus 1. And I'm just going to write this as x minus 9. Okay. Are we done? Have we solved how many skateboards we have to sell in order to break even?
No.
What do we have to do next?
No.
What do you call that? Well, 0.
We'll just solve for x. Right. Well, I have this negative 7 here. Okay. And what this really says is negative 7 times this entire bracket equals 0. Okay? Well, we know negative 7 is the value of negative 7. Okay? But these two brackets here, we don't know what they equal. And in order to create a 0, one or both of them will have to be equal to 0. So, a lot of people get confused when we have a common factor. The best way to think of it is like we're going to get rid of that common factor. We're going to divide both sides by negative 7. When I divide 0 by negative 7, what do we get?
0.
0. And the negative 7 and negative 7, what value do they actually create?
0.
Not 0.
1.
1. Okay? They actually create a 1, but when we multiply these values by 1, it doesn't change anything. So we call it canceling out usually. Okay? So let's say they've canceled each other out, and we're left with 0 is equal to 2x minus 1 times x minus 9. Now again, one of these brackets needs to be 0 in order to multiply to get 0. So we're going to test both of them out. We split the equations. We'll get 0 is equal to 2x minus 1, and 0 is equal to x minus 9, and we'll solve for two values of x. And remember, because this is a quadratic shape, there'll probably be two x-intercepts. So, to solve for x in this one, we bring 1 over. That becomes 0 plus 1 equals 2x. And over here, it becomes 0 plus 9 equals x. What's 0 plus 9? Just 9. So one of our values is x equals 9. 1 plus 0 is just 1, right? And we still have to move that 2 over, so we divide both sides by the value of 2. And our x value is actually a half. Okay. So if this is an actual value of skateboards where we only have to sell 9 skateboards or a half a skateboard doesn't really make sense. What we're going to say is maybe this is being represented in the thousands. So if it's represented in the thousands, this would mean they need to either sell 9,000 skateboards, or what would this value represent? 500. 500.
My name
Because
is Nader.
half of 1,000, right? So that'd be 500 skateboards. Now, how are we doing with time? Okay. So, how does this make sense where they have two break-even points? Instead of graphing it right away, I also want to solve what their max profit will be. Okay? Now, the reason we know they'll have a max profit and not a minimum profit is because the A value, okay, right here in our standard form, the A value is a negative, which means we're going to have a graph that is facing downwards. In other words, it'll have a maximum. Okay? So that means they'll have some max profit. Using the information we have at the bottom, how can I find max profit using this 9 and 1/2? Plug it into what? Yeah, so we got to find the axis of symmetry, right? Our axis of symmetry, we call it the AOS, is where we take the two x values, usually known as R and S, and divide them by 2 after we add them. So, let's add them together. What is 9 plus a half?
Around 9.5.
Exactly. 9.5 divided by 2. What will 9.5 divided by 2 be?
Around 4.7.
Is it 7.5? Yeah, I think you're right. It is 7.5.
Yeah.
So, again, if they're talking about thousands of skateboards, what would this value be to maximize profit? 4,750. So, because we're going to assume they're talking about thousands, they would have to sell 4,750 skateboards to be at a max profit. But what would that max profit be? How much money would that be? How do we solve that part of this equation? We plug it in. Now, which one do I plug it into? Do I plug it into the factored form we have over here, or do I plug it into our standard form we started with?
Standard.
It'd be easier if you
Either
did the
one
second
works. It does not matter.
Which
Okay?
one's easier?
To be honest, I think the factored might be easier.
Which one?
Just because here, if you have a calculator, it's really not going to make a difference, right? You're going to plug it all in one shot. But if you're trying to do this using mental math, it'll probably be relatively difficult to multiply 133 times 4.75. Where here, we might be able to work with some numbers that are a little easier. Okay?
Alright,
Either will work, and I'm going to plug it all in one shot anyways. Who's got a calculator can help us out here?
no.
All right, so I quickly wrote it in. First of all, yes, this was question B. And we took the original profit function in standard form. And because it was P at X, we were plugging in the X value of 4.75. We plugged it in, and let's assume that, again, is in thousands. So if they sell 4,750 skateboards, if this is in thousands, the amount of profit they'll make will be 252,875. Okay? Even though this was a decimal here, we had to convert it to thousands, right? So, now that we have these values, we're going to quickly make a sketchograph here. And what I mean by sketches, I mean it won't be perfect. We're just going to put our major values on to get an idea. So remember, one of the values was a half. Another value was 9. 4.75 was our max amount. And we're going to call this say 3, okay, approximately 3. So that would be our highest point, our vertex. So what this means is we have some parabola that goes up like this, comes down. So there are 2 break-even points, okay? And the one last thing I do want to ask very quickly, what is the y-intercept? Look at standard form, what is it? Negative 63. So let's try to make sense of this. We'll say this right here, it is negative 63. When they sell 0 skateboards, if this is in thousands, how much money do they make or not make? They lose $63,000 if they don't sell any skateboards. Makes sense, right? If you don't sell anything and you produce a whole bunch of stuff, you have overhead costs, you lose money. Eventually, they come up to the point of, again, it's in thousands, so it says a half, but let's say it's 500. Once they sell 500 skateboards, they're now at a break-even point. They've covered their overhead costs, let's say. Then, as they continue to sell skateboards, they come up to 4.75 or 4,750. They'll be maximizing profit at around $253,000. Then, they start selling more. In a business sense, what do you think might be happening here?
People have a lot of skateboards, so they stop buying, and then it goes back to negative.
Well, this is an economics question. There are still buying skateboards. We're selling more than 4,000. That was a good idea. But sometimes in business what happens is there's an efficiency point, okay? And it's actually costing us more money than we're making to produce even more skateboards. We have to run the plant longer. We have to keep the lights on longer. So it's no longer efficient for this company to sell more than 4,750. This will be their maximum profit. Okay? At this point, the costs become too much and they start losing money again. And once they get to 9,000 skateboards, they're at a break even. If they sell more than 9,000, it is costing them more than they're selling them for. So it makes no sense to do that. Okay? So that's what this means in a business sense. Well, you don't sell that many. Only make 4,700.